No. After first grade.
Alright, focus!
And I come back and I'm like,
For number 1, Ray, phone up. Ray, phone up. Thank you. For number 1, we are solving for M. So we need to get rid of the 2 by multiplying. Jacob Wilbur. And then divide both sides by b squared. So 2k over b squared equals m would be our equation.
That's my dream.
Questions on that one? Number 2, we are simplifying Jacob. Yes.
What is the math school?
December something. I don't have the exact date. I can look for it and let you know. Not right at this moment.
Well, you could take it in December. They have to sign up for it. No, you have to.
They're behind. So, do you have any on the shelf please or anything? No, no. It should be on the shelf behind on the lower shelf.
All that I got is this app.
You don't see them.
You
Refocus.
want me to get to the thing?
Oh, I've been drinking it water.
Alright, for number 2, we are simplifying, so we just need to distribute everything. So I'm going to multiply as is for right now, and then I'll simplify, but if you multiply it in the calculator, it simplified it for you. So this would be 28 40ths x plus, whatever that is. My calculator's not over here.
Wait, 28.
Did I mess up? Yeah, 28 is 7 times 4, and then 8 times 4. And then, yeah. Wow. 112 over 8 plus 3 over 10x minus 30 over 5. Then if you simplified, so if you put this directly in your calculator, it simplifies it for you. 7 tenths x plus 14 plus 3 tenths x minus 6. Then combine your like terms, so the ones with x's and then the constants. This would be 10 over 10x plus 8 or x plus 8. What's the final answer? X plus 8 was the final answer. Questions on that one?
When I put mine in the calculator, it was already simplified.
To 7 tenths. Yeah, that's fine. I just was multiplying it all out because I couldn't do that in my head. Alright, the intercepts for this one, there aren't any x intercepts, so none, and a doesn't exist, whatever, just don't put 0 or x. For the y intercept, there were 2
That was so comfy.
at 1 and negative 1.
You can tell me he's not comfy.
Questions on that? Okay. So we are going to start our next unit. It's on inequalities. Most of you have seen them, have solved for them, so this should be really easy today. We're going to go through the lesson. Should not take that long. And then afterwards, you can use it for flex time, other schoolwork time, whatever you would like. So pay attention to this lesson, and then afterwards you could do really whatever.
Yo, I can't see so close.
You look at your course calendar really quickly. There are 4 days of lessons. Today's the first one. And then your review and quiz and tests within the next few weeks. Really 2 weeks. So quiz on the 6th, test on the 8th, flex day the day after that, unless we have 2 days in between that.
Hopefully.
If you have not finished your Unit 3 test, it needs to be done no later than the Thursday before our next test. So 12/7. You could finish it today before Thanksgiving break. I would highly advise that you finish it today because you're not going to remember next week. But keep that in mind. Also, let's do this before we do notes.
The size.
This is the assignment that was due on Friday. The Delta Math assignment that was due on Friday. 7.9% of you completed it, which was not your 50, so you do not get gum. You do have Delta Math on what we're going to do today that's due on the 1st. You can easily get it done today. So that when we check it after the 1st, it's done. Right. Everyone should have these notes in front of them. We'll start this very briefly before lunch and then come back and finish, and then the time will be yours after that. So if you have your computer open, please close it. Close it.
I'm hungry for brownies.
Close your laptop.
Oh.
I want brownies so bad. I remember that. I don't remember any.
Alright. For these, we're going to use an open circle. Guys, for less than or greater than signs. And a closed circle for less than or equal to or greater than or equal to signs. Right? So to kind of help you remember which is which, when you think strictly less than, strictly greater than, please stop talking. You're thinking it's not part of the solution set, it's open. The closed circle, it's included in the solution set, has the equal to with it, it is equal to, so keep that in mind. So there are multiple pieces to this. One is being able to graph the inequalities, so let's do a couple of these. If we had to graph x is less than 3, this would be an open circle at 3 going to the left.
Yeah.
Most of the time, whatever direction this is facing is going to be the direction that you're graphing, but sometimes that is not the case. So if this were switched, these mean the same thing, but you have to read it backwards. 3 is greater than x is the same thing as x is less than 3. It would still go to the left. Questions on that? How would we graph 3? Would that be open or closed? Closed. At 7. Going to the left or to the right? Right. And if you're not certain, you can pick numbers and put them in. So if I put 8, 8 is greater than 7. That works. 10 is greater than 7. That works. So I know I'm going to keep going that way. And if I put in 6, 6 is not greater than 7. I would not be going that way, to the left. Really quickly, then it has the opposite. Now, you're given the graph and you have to write the inequality. So for number 5, it's open, so it has to be less than or greater than, strictly less than, strictly greater than. But because it's everything below that, that would be less than, x is less than negative 2. What would 6 be? close. Because it's close, it would be greater than or equal to. Alright, when we come back, we will start this next part.
Let's go.
Oh shit, let's go.
Doesn't look at girl in front of me.
Llegó un paquete de stickers. Soy pedífica, no pedí.
Okay, there is one major rule you need to remember. Flat off the way. You must flip the inequality symbol when you multiply or divide. By a negative number. So if at the end you're solving and you get, I'll give you examples. Make sure your phone gets put up. If you have something like negative x is greater than 6, when you divide by negative 1 on both sides, the sign changes directions. But if you have like x is greater than negative 6, and you, I'm sorry, let's change that to 2x so we can actually divide. Here we're dividing by a positive number, so the sign would not change. So it depends. If you're dividing by a negative, the sign changes. But if you're dividing and the result is negative, you do not change. All right, we're going to do some examples. So these examples are very similar to regular equations. Solve them the exact same way. The only difference is they have inequalities. Gabriel, you have note? Did you grab your notes? Yeah. Okay. So for number 9, if we were solving this one, we would get rid of the 2 by subtracting. And then divide by 3. Would the sign change here? Yes. No, because we're not dividing by a negative. What we're dividing by happens to be negative. So x is less than negative 2. And then we would graph this. So you can fill out these numbers to be whatever you want. You do need to fill out the graph. I usually put this number in the middle and then go forwards and backwards. So forwards, negative 1, 0, 1. Backwards, negative 3, negative 4, negative 5. What do you say?
Could you start with 0 and then have...
As long as it's in there somewhere, it doesn't matter. Right? Would this be open or closed? Open. Going to the left or to the right?
Left.
Solve. Get your final answer. Graph. Questions on that one? Do we want to see 10 before we go on to the next page?
Yeah.
Yes. Alright, so how would we start solving this?
-3.
So we could multiply, we have to multiply everything by 6, but the easier part would probably is to subtract 2. And then multiply both sides by 6. Is the sign going to change here? No. Now if I was multiplying by negative 6, yes. Right? So make your line however you want. You go negative 18, negative 17, negative 16, negative 15, negative 19, negative 20, negative 21. You could also skip numbers, count by whatever you want. It's your number line. Open or closed? To the right or to the left? on to the next page. Gabriel, put your phone up. Okay, so this part is something we're going to cover again in a later unit. We're just going to do it now so that when you see it later, it kind of, something clicks and you're like, oh yeah, we did this before. But if you don't completely get it right now, it's okay. So, what we were doing before when we wrote the answers, x is greater than 6, was your set builder notation. Gabriel, I need you to set up. Thank you. There is also an interval notation where you use parentheses or brackets. So think about if it was open or not included, those are the words I used before, or if you had strictly less than, strictly greater than, you're going to be using parentheses. If it had closed circle, it would be included, or it was less than or equal to, greater than or equal to, you're going to use square brackets. But we always use parentheses with infinity or negative infinity. So that means if x is greater than 6, it's going to start at 6, but it's going to end at infinity. That end part is where we would use a parenthesis. So let's do some of these. So with number 1, how would we start solving that? Sure. So 4x plus 12 is greater than negative 24. Our next step. Subtract 12. We have 4x is greater than negative 36. Divide both sides by 4. Is the sign going to change? So x is greater than negative 9. Let's go ahead and graph that part, and then we'll talk about the interval notation. Open or closed?
Open.
To the right or to the left?
Right.
To the right. So this would be everything greater than negative 9. Okay, so your interval notation, you're going to write where does it start, where does it end. So this one starts at negative 9 and it's open. You're going to do parentheses, negative 9. Where would it end? Infinity. It would keep going. So it's going to go past negative 6. It's going to go past whatever you wrote on yours, all the way to positive infinity. And you're going to put a parenthesis. That is your interval notation. It means the same thing as this. These two mean the same thing. Questions on that so far? Let's do number 3. How would we start that one? Distribute. So we have 7x minus 2x plus 8 is less than or equal to negative 2. So we have 7x minus 2x, which would give us 5x plus 8 is less than or equal to negative 2. Then the solving part is the same as everything else. Subtract 8. And divide both sides by 5. Is the sign going to change here? No, because we're not dividing by a negative. Okay, so go ahead and make your number line. Would this one be open or closed? Closed because of the equal to. Going to the right or to the left? To the left. Everything less than or equal to negative 2. Right, so now if we're doing our interval notation, where would this one start? That's where it ends, but left to right, where would it start? If this thing's going negative infinity. So that's going to be negative infinity in parentheses. It stops at negative 2, but this is a closed circle, so you're going to do a square bracket. there any of the ones that we skipped that we want to see you go over on this page? 4. Alright. So first step, very similar to the last one, distribute. We have negative 8x plus 8 minus x is less than or equal to negative 28. Combine your like terms. Negative x plus 8 is less than or equal to negative 28. Subtract 8 on both sides. And divide both sides by negative 9. Is the sign going to change for this one?
Yes.
Yes, because we're dividing by something that's negative. So let's make our number line. Closed or open? Closed. At 4, going to the right or to the left? To the right. So if we write our interval notation, where does this start? 4. Would that be a parenthesis or a bracket? Bracket. Square bracket, 4 closed. And then where does it end? Infinity. And that would be a parenthesis. Look at the next page. Are there any questions on that page we want to see you go over and have questions about? Okay. 7. Okay. Right. When we have variables on both sides, we have to get all of the x's or variables on one side, all the causes on the other, same as before. So I could, and you have choices, move 2x over. You could do this at the same time. I'm just going to do it step by step. And then by default, move 20 over. And divide both sides by 3. Would the sign change here? No. Because this is still positive. So I'm going to write this as I have it right now. But if that is confusing and you would rather the x be on the left, you could change the whole thing. Just whatever direction it's pointing to or away from the x, make it the same. So when you flip it, this would be x is greater than or equal to negative 7. These are the same. So make your number line. Would this be open or closed? Closed. Going to the right or to the left? They're two different things. If it's greater than negative 7, it's going to be the numbers getting bigger, or the ones that are less negative. So to the right. Your number line does not have to match mine. Where does it start? Would that be a parenthesis or a bracket? Bracket at negative 7, and it goes to infinity, positive infinity, because the numbers keep getting bigger. Questions on that one? Okay, and then let's do number 7. Alright, so for this one, we want to distribute on this side first. So 3 minus 2x plus 7 is less than or equal to 34 minus 6x. Combine like terms on the same side. So the 3, the plus 7, that becomes 10. Then you have choices. What do we want to move first? 10. Sure. So if we're moving the 10, we would subtract 10 on both sides. And then move the 6 over by adding it to the other side. So that we have 4x is less than or equal to 24. Divide both sides by 4. X is less than or equal to 6. Then make your number line. Would this be open or closed? Closed. Going to the left or to the right? To the left. Everything less than or equal to 6. Right? Where does this one start? Negative infinity. And ends at 6. Would that be parenthesis or bracket? Are there any others we want to see and go over on this page? Or anything we have questions about? So then, for the remainder of class, I'm going to give you some things you can be working on, but you don't have to do these things. If you would like to continue working on this, you have problems that we skipped over, you have the back page, you have the delta math on this. You have missing delta math that you could be working on. If you haven't finished your test, you could be working on that, / practicing for it. You could be working on retake work, or you can grab your phone / do other things.
Wouldn't that be?
Do that one more time.
Wouldn't it be 4x?
Where, right here?
Oh, yeah.